All right, lads, gather round. Every single one of you probably has a drawer full of these. Dull, snapped, or just plain old utility knife blades. But today, we're not wasting anything. We're turning this pile of disposable trash into a piece of art. If you love seeing scrap turn into stunning tools, smash that subscribe button now. First things first, stacking. You need to make a solid billet. We're stacking them up high to get enough volume for a decent knife blank, aiming for a tight, high-density stack. I'm using a simple clamp to apply initial pressure. Safety first. Even if my helmet looks like it belongs in a heavy metal video, we need to tack weld the entire perimeter because you absolutely cannot have oxygen getting inside, or the iron oxide will prevent the weld. This tack weld creates a mini, temporary steel can for our layers using a standard MIG welder, keeping the amps low. Get a nice, solid bead all the way around, creating a firm container for the loose blades. This is essentially the can method in Damascus forging, just without the actual can, which is a big time saver. Done. Removing the clamp and welding on a temporary handle. This small piece of round stock will save my fingers later when I get this thing up to 1150 degrees in the forge for the actual weld. Time to swap my delicate gloves for the actual heat-resistant ones. Now into the forge. We're running a coal forge today to get nice, high, consistent heat for the first wash heat. This initial heat will bring the billet up to around 800–900 degrees to burn off any surface contaminants before we aim higher for the actual weld. Now for the magic dust. This is welding flux, typically a compound of borax or a commercial anhydrous mixture. When it hits the hot steel, it melts, dissolving any iron oxide, scale, and acting as a barrier to prevent more oxygen from reaching the layers. It creates an airtight liquid shield, and without this, the weld fails. Back in the fire. We need that flux to bubble and melt into a glassy protective layer. When it reaches that perfect viscous consistency, you know it's ready. The stage for the most satisfying, mesmerizing part of the whole process, the moment where all the noise and chaos come together in liquid perfection. Just a quick cleanup of the shape. If you see the famous salt shaker in a shop, you know it's for flux, not seasoning. The Damascus process has officially started. Time to call in the big guns. Crank the heat back up to that scorching 1200 degrees sweet spot, where the metal practically hums with potential. Forget about relying on raw arm strength. This is the moment the hydraulic press steps in, taking the strain off your back while you focus on precision. The power press isn't just faster, it applies constant, even pressure deep into the billet, ensuring the weld is solid all the way through, especially important for our thick, multi-layered block. We are drastically reducing the thickness and simultaneously increasing the length in the drawing out process, turning our small, thick billet into a long, flat bar suitable for a knife blade. Now back to the traditional anvil to manually forge the profile. Then, moving to the tang, that's the part that goes into the handle, making it thin and strong with the metal manipulated at a lower forging heat, perhaps 900 to 1000 degrees. The next heat is all about setting the main bevels. I'm angling the hammer strikes to push the material out, thinning the edge without hitting the actual cutting edge. We'll grind that later. Forging the bevel saves hours of grinding later. This is where you really start seeing the knife take shape. Look sharp at that edge. We've hammered this beast into shape on purpose. See that jagged sawtooth pattern? That's not a mistake. That's our signature, our little middle finger to boring knives everywhere. Every ridge, every groove screams fire, sweat, and pain. It's the kind of edge that doesn't just cut, it intimidates. And there she is. Ugly as sin, coated in scale, but solid as a brick. You can almost hear it mocking you, daring you to touch it while it's glowing like a damn furnace. That subtle, ruthless profile, that's the knife you'll respect when it's done. But for now, it's far too hot to handle. So let it cool and prepare yourself for the part where the real noise, the real chaos, begins. Grinding time. We have to strip all that black scale, which is mostly iron oxide, and smooth out the hammer marks. This is where we define the knife's geometry. I'm using a 90 grit ceramic belt to aggressively remove material, maintaining the forged bevels. See the profile starting to emerge? We need to ensure the blade is straight, the tip is centered, and the thickness is even before we add the final critical steps. We're aiming for a consistent taper from the spine to the edge. Just a quick, loud cut to size the tang properly. Always wear your safety glasses, or you'll regret it for the rest of your life. Now, defining the blade spine and the ricasso, the unsharpened part before the blade. Using a coarse flap disc on the angle grinder to move material quickly and precisely. You can't be afraid to take off material quickly, but precision is key here. The tricky part, those serrations. I'm hunched over with a round file, painstakingly carving each valley between the teeth one by one. It's slow, it's brutal, and it tests your patience and your sanity. Every groove has to be perfect, because this is what gives the knife its unique, aggressive, serpentine personality. Take a shortcut here, and the whole edge looks like a joke. You don't want that. Once the manual filing is done, I move in with the grinder to clean up the points, sharpen the attitude, make it lethal. Sure, I could have hammered out a standard Bowie in half the time, slapped a polish on it, and called it a day. But where's the fun? Where's the challenge? Where's the glory in that? This isn't just making a knife. It's sculpting a weapon that looks mean and performs even meaner. This serrated edge will bite into whatever it cuts, something a straight edge can't match. A final cleanup pass with the grinder will remove any deep scratches and bring the whole surface to a uniform finish. The geometry is now locked in. Next up, the heat treatment, which turns this nice piece of metal into a hardened, functional blade. This is the hardening heat, critical, where we need to hit the non-magnetic point and maintain that heat for a few moments. We need to allow the carbon in the steel to fully dissolve into the solution, forming austenite, usually about 815 to 870 degrees for most high-carbon steel. If it's too hot, the grain structure grows too large, making it brittle, too cold, and it won't harden fully. Precision is everything. Note the respirator. The oil quench is coming, and you don't want to breathe those fumes. The quench, into the engine oil. This rapid cooling locks the carbon in the crystalline structure, turning the soft steel into hard but brittle martensite. It's going to smoke, steam, and occasionally flame up. Do not try this indoors without proper ventilation. Now into the sand-tosh abrasive mix. This immediate cool-down step cleans off the worst of the oil. If you want to see every brutal, satisfying step of this process, make sure you hit that subscribe button. Don't miss a single cut, spark, and hammer strike. The blade is hard, but now it's brittle. Tap it too hard and it snaps like a biscuit. Before we temper, we need to clean the surface of the blade to see the oxidation color change, which indicates the tempering temperature. It has to be precise. Now for the Damascus pattern reveal. We're dipping the blade in ferric chloride, a strong etchant. The different steels in the billet react differently to the acid. The high nickel layers resist the etch and stay bright, while the high carbon layers etch dark. This is how you make the pattern pop. There it is, subtle, but definitely there. Proof that our layers welded up properly. Time for the handle. I'm using a gorgeous block of stabilized wood for the main handle and a piece of green composite material for the front guard. Measure twice, cut once, especially on pricey handle material. I'm marking the tang dimensions, drilling out the waste material with the drill press. Now I'm using a needle file to painstakingly fit the slot to the tang's exact shape. This must be a tight, zero-gap fit for a professional finish. Then, drilling the main handle block now, a hole slightly smaller than the tang, widened to the exact size, guarantees a tight fit for the epoxy. Speaking of which, here's our two-part epoxy. The stuff that doesn't just stick things together, it practically fuses them into one unstoppable unit. Mix it thoroughly. Sloppy work here, and you'll be hearing about it later when the handle starts wobbling under pressure. Coat every surface. Guard, wood, tang like you mean it, leaving nothing bare. Slide the pieces together slowly, making sure everything aligns perfectly, straight as an arrow. Clamp it down tight, no mercy, and let it cure. This glue is the backbone of the handle assembly, the silent hero keeping your creation from falling apart. And if you do it right, it'll feel like it was never separate in the first place. The glue is set. Now the fun part, shaping. I'm using the angle grinder again to quickly round off the sharp corners and mold the rough square wood block into an ergonomic, comfortable handle. This is an artistic step, sculpting the wood to fit the hand. Look at the wood starting to show its grain. Careful sanding is the only way to make the handle comfortable and durable. The round stock handle is perfect for a full grip on a hunting survival style knife. A quick buff with the polishing wheel and some compound brings out the shine and depth of the wood and the brass accents. Buffing the brass guards is key, as that contrast with the wood and the Damascus steel is what gives the knife its high-end finish. We're removing those micro scratches and making it feel amazing in the hand. The sharpening jig. Since we set the bevels in the forging, this final razor edge should take only minutes. We are finishing the edge at a very precise angle to match the aggressive profile of the serrated edge, which is a crucial step that makes a tool a great tool. The ultimate test, the playing card shred. That's a sharp edge. It cleanly slices through, proving the heat treat was a success, and the steel is properly hardened and tempered, and shaving paper-thin curls off a block of wood. This knife is ready for any bushcraft or utility task you throw at it. The old candle trick. A demonstration of finesse and a well-balanced blade. Clean cuts without disturbing the flame. Perfection. Just to make sure it holds up, a proper throw into a log. The handle is secure, the tang is solid, and the blade is tough. And there we have it. The scrap pile challenge is complete. We turned a pile of disposable utility blades into a tough, beautiful Damascus steel survival knife. It's got a gorgeous wood handle, a stabilized resin guard, and a serrated edge that means business. Remember, there's no such thing as scrap, just raw material for the next project. If you love this transformation, hit that subscribe button for more forging madness. Drop a comment below and tell me what you want me to forge next. Stay sharp, boys!